Welcome to Programming Rainbow. In this video, we will continue on the series of Conway's Game of Life. This is the second video, so if you're just starting out with this video, you'll want to go to github.com. Let me show it to you real quick. You want to go to github.com, Programming Rainbow, Conway's Game of Life, and this will be Love2D. You can just copy this URL, and then in a terminal you can git clone it. We've already done this. And then you can move inside of that directory, open up whatever editor, text editor, or programming environment you want to use. I'm using NeoVim here. And this is what you'll see. You'll see the fonts, images, video 1, 2, 3 folders with all the code inside of them. This is the code we just left off with in the last video, and the README in the screenshot. So if you're just starting out with this one, since this is the second video, you'll want to probably remove the code with RM, and we'll use the wildcard Lua to get rid of all these 3 Lua files in the top level directory. And you'll want to copy in the files from video 1, since that was the last video, so you can be right where we are right now. And I'm going to use, again, from video 1. Okay. We're going to look at the code that we ended off with video 1, but I did make a couple little changes since the last video, just minor ones. So this is where we left off. We're able to draw a game. It's gridded, and it has some of the cells lit up and some are not lit up. And I can clear it. I can make another random, but it doesn't actually go through the updating process just yet. And what I've changed since the last video, let me go show you, is I've changed this to 1400 by 900. Now, if your resolution doesn't support this, if you have a screen that's less than this, just go ahead and change this to 800 by 600, okay? But I've gone ahead and changed all the code over to 1400 by 900. It's just these 2 lines that I changed. And if you like to see bigger cell size, we could just change this to 30. We could put this to 5. Doesn't really matter. And now we have big cells. Okay, so that's where we left off with. And I just wanted to show you, like I said, I just changed that 1400 to 900. It used to be 800 by 600. That's whatever you like yours to be, just set yours as you want. You probably want it slightly less than your monitor can show. Okay, so in this video, we will be implementing the game rules to the 4 rules to the game of life. And do I still have the wiki? Actually have it written down right here as well. So these rules are written out differently. It's basically if you have a dead cell that has 3 living neighbors, that cell will become alive in the next generation, in the next tick over. So if you have a live cell that has 2 or less, less than 2, if it has 0 or 1 neighboring cells, it dies. If it has more than 3 cells that are alive that are touching it, it also dies. So if it has 2 or 3, it stays alive. But I think they broke them up into 2 different rules. Any other cell dies or remains dead. Okay, so they word it in different ways, but basically I just look at it as in if a cell has 3 living neighbors that's dead, it comes to life. Any living cell that has 2 or 3 neighbors that are alive stays alive, and all other cells die. So I just put it as 3 rules, but it doesn't really matter. The rules are the same no matter what. It's just how you kind of look at them. So we're going to implement these rules into our update. And I don't think we're going to be looking at anything in Love today. So game update, down underneath we got reset, we got draw, clear, above draw, and below clear, I'm going to create a new method called game update. And what I want to do with this is I want to iterate through the whole table just like I've done before. So I'm going to go ahead and grab one that I've already got. I do want the value, so it's going to look exactly like this. I'll just put the 2 ends on it. Okay, that just helps me loop through the table. It says I'm not using it in anything. I'm just copying a bit of code so I don't have to rewrite it. So what I want to do is I want to be able to count. So I'm going to go through for each one of the values in this table. I want to look at that position and I want to count all the values around it. So imagine if you have so down here. So if I'm looking at this value right here in the table, if I'm looking at this 0 value in the table, I actually have 8 cells around it that are touching it. So there's 9 altogether, but the center one is not counted because it's the actual cell that I'm looking at. So for every single cell in this table, I'm going to look at all the cells around it. And I want to follow those rules. So if this cell is alive, I want to see if I want to count all the cells around it and say, is there 2 or 3? If anything other than 2 or 3, this cell is going to die. If this cell is not alive and I have exactly 3 living cells around it, then this cell's come to life. Everything else, this cell's going to die. No matter if it's dead now or if it's alive, it's going to die. So the other thing I'm doing is imagine what happens in the edge cases. Let's say I'm looking at this cell right here. So I'm at this cell right here, and I want to look at the cells around it. What I'm going to do is I'm going to wrap this. So when I need to find the cell over here, that doesn't actually exist, but I'm going to use a modulus operator, and I'm going to look at the cell here. And for this one, the cell above it, I'm going to look at the cell down here. So anything that's on a border, it's going to wrap around and look at what's on the opposite side of the screen. That's just the simplest thing that I could figure to implement. And that means if anything goes off the screen, say a glider, it'll actually come back on the screen. If it goes off the top of the screen, if it glides off the top, it's going to glide back onto the bottom of the screen. So that works pretty nicely. So I'm going to be using that to, so imagine if this is our table and it was 3 by 3, we would go through each one of these, and for each one we would count all the ones around it. And the next one, count all the ones around it. And that's the way we're going to implement. And since we have this two-dimensional table, we have to build a new table from it. So I'm actually going to have 2 tables. I'm going to be reading from one table to implement onto the second table. And then I'm going to just keep swapping them, kind of like if I was swapping a buffer or something. So I know we are creating one table, above called board. I'm going to have another table called next board, and I'm just going to be switching them back and forth. And I'll show you what I mean here in a second. So up here, I have a board, but I do want another board. I'm going to call it next board. And this board needs to be the exact same size as the original board. So right down here where I'm populating this board to fill out what size it'll be, I'm just going to piggyback this and populate the second board as well. So we'll say next board, and we're going to do the exact same thing for the row, creating the row. It's a new table each time. And down here where we're filling in that row with columns, I'm going to do the exact same thing. Call it next board. Okay, now we don't need to do anything with reset, clear, any of that stuff. We just need to make sure this board exists and it is the correct size. So it has all the rows and all the columns that exist in the board. These 2 boards are going to be the exact same size. If I were to do something like this, I just want to show you what I initially tried to do, and I couldn't figure out what was going on, and then it reminded me of Python. So if I have, let's say inside of the update, just for argument's sake, say inside of this update, I wanted to make a second board, a temporary board, so I could, of the same size, and then just start writing into it. So if I did this like local, and I've put like new board, and I had it equal to self.board, right? This is a problem because this does not copy the board. What this does is it copies the address to the board, the actual in Lua, what's happening under the table is there's an actual address that's involved here, and it's going to copy the address. So both of these, sorry, what am I doing here? New board. Sorry, the equals is not right. So this new board will actually equal the second board. So normally if you have a variable, I could put a value in that variable and I could change it to a new one, and that's fine. And I could say, you know, if I said local number num1 equals 5. Come on now, the autocomplete. And then I said a local num2 equals num1. What this is going to do is it should give me the value. But on these tables, it doesn't. On the tables, I'm going to get the actual table. So when I go to change anything in this new table, it's actually going to change the original table. So while I'm trying to read from board and put the answers into next board, I'm actually putting the answers into board. So I'm reading from the thing that I'm mutating at the same time, and that becomes a huge problem. So don't make the mistake of setting a board to another board or a table to another table, because it's going to be the address of the table, not the contents that are inside the table. You're actually going to have access to the exact same table. So that's why up here we are creating a completely different table, a new board. So we have two of them to work with. We'll be reading the values from one and setting the values in next. And then we could just swap back and forth whichever one we want to use, and we'll see that. But so there's not one board being referenced twice. In fact, there's two boards. Okay, so yeah, I'm going to delete this here. Hopefully we can get some code in here and starts complaining. So yeah, so what I want to do is iterate through the first board, and I want to count everything that's happening around each item, and I'm going to let it wrap around. So the first thing I need to do is make a variable called count. I'm going to set that to 0. Now, what I want to do is I need to, like I said, I need to look at the 8, everything that's touching my cell, the 8 cells that go all the way around my cell and touch my cell. So the way I'm going to do that is I'm going to take what row I'm in, I'm going to say Y is row -1, row -1 to row +1. And I'm going to say X is column -1 to column +1. But then I'm going to use the modulus. But because Lua's 1 base, this becomes a headache again, and we have to work around it. But we'll get past it. So I'm going to say 4Y equals row -1. So basically, I'm saying whatever spot I'm at, if I'm iterating through this table, when I'm at row, I need to check everything from row -1 to row +1. And for X as well. Okay, so that is going to allow me to, this first for loop right here, these first 2 for loops are letting me go through the table and get each value out of the table. These next 2 for loops are now taking that spot, not that value, sorry, that actual spot in the table, and looking at the 8 touching ones around it. And it's actually 9 right now, but we'll get rid of the center one in a minute. Okay, so now we need to check if we are actually the same. So we don't want to count the center one because that's the one we are. That's the specific cell that we're in is the center cell. So there's 9 cells involved, but we only want the 8 going around the center because the center one is the cell that we are. So we're going to make sure that we're not looking at the center cell. So if row equals Y and column equals x, we are at the center cell, right? Row can be equal to 9, and column could be, x could be column +1 or column -1, but they can't both be equal. If they're both equal, then we're talking about the center square, and that's not, we can't use that one. So I'm going to say if not, and in here I'm going to say row is equal to y, and column is equal to x. Okay, so what's going to happen is this in parentheses is going to turn into a Boolean if the row is equal to 9 and column is equal to x. If this is true, we're in the center square. Okay, and we don't want to do anything in the center square, so I have a not if not. So I want to do everything except when it's, as long as it's not the center square. Okay, and now we're going to do the wraparound. So I'm going to create two local variables again. I'm going to call it wrapped row. And this gets a little funny because of the Lua being 1-based. If we wanted to use modulo, it doesn't work if it's 1-based. So the way modulo works is if, say, we can go from 0 to 9. Yeah? If I'm at 10th, the 10th spot, and I do modulo 9, it's going to be 1. Okay? That's if I'm going 0 to 9. But if I go 1 to 10, I have problems because what happens when it's 0? Well, it should never be 0 because it always needs to be 1. So what I need to do is I need to say, I need to take y and I need to subtract 1 from it. Then I need to run the modulus on it. And then I need to add 1 back to it to set it back to what Lua needs for its 1. So to run the modulus on this, I have to -1. And then when I'm done with the procedure, add 1 back to it. So it's going to look something like this. So I say y minus 1. And this modulus is so that you can wrap around. I hope everybody knows what the modulus operator does here. This is the, so if I have 0, to 10, or 0 to 9, right? And my answer always needs to be between 0 and 9. If I take something like 15 modulo 9, okay? Well, it's going to go 0 to 9, but 15 is past 9. So what I'm actually going to get, this is going to equal like 6. Okay? 10 is 1. So it just causes it to wrap around. Okay, so I'm saying this, and the modulo that I'm using, or what I'm checking, it is self rows, which is the maximum amount of rows I can have. Self rows, and then on the outside, I need to add that 1 back because we're 1-based in Lua. So all this is because Lua is 1-based. And I'm going to do the exact same thing with the wrapped columns. Say x minus 1. And then I will do the modulus on self.columns. And then plus 1. So that allows the number to always be inside of my table. Never to be too small or too big, so there's no error, and it allows it to wrap around the screen as well. Now that we've done that, so we know we're not the center one, and we're only counting the ones around us now. So that's, for each column in here, for each row and column, We are now looking at the 8 around it because we were cutting out the center one, and we're making sure it's wrapped. So if it needs to wrap around the other side of the screen, we're doing it. Now we're going to start counting what's in there. So what I'm going to do is I'm going to say count equals count plus, and I'm going to say self board, and I'm going to use the wrapped column or wrapped row and wrapped column. Wrapped column. And so I'm just adding it because this is either going to be a 0 or 1. So if it's a 0, I'm adding nothing. And if it's a 1, meaning it's alive, I'm adding 1 to the count. So that's going to tell me how many live cells are around this. Okay, let's see what I've done wrong here. Oh, I'm missing one. That's what it is. Okay. So this is just getting the count. This isn't updating the board or anything. That's all this is doing. So basically, for each one of these items, when we're inside this these 2 for loops go to each one of these. So I want to be at the same level as this. I'm running this loop, counting all the live cells around the cell I'm looking at. Now I need to say, is this cell, I need to start implementing these rules. So the first thing is this cell alive? Because I know if the cell is alive, around the cell can only be a 2 or a 3, right? So the value is telling me if the cell is alive. This value right here is either going to be a 0 or 1, and that's telling me is the cell I'm looking at right now alive. So if value equals 1 and count, so the living cells around that are touching this, if it's bigger than 1, that means it's a 2 or higher. So greater than 1, and count is less than 4. That basically means it's going to be a 2 or a 3. Okay, so if the cell is alive and the count that we just went through this loop to populate this count, if the count is bigger than 1 and less than 4, that means it's either a 2 or a 3. We want this cell to be alive. So we'll say self, and we're going to put this in the next board. We're not mutating the board we're reading right now. We're mutating the board that we're not reading, which is the next board. And we're putting this in row column. So we're reading from row column, and so we're putting it in the next board in the same exact spot in the next board, whether this should be alive or not. And we're going to have it equal to 1. Okay, so that's kind of 2 rules in one that I'm doing. So if it's not alive, I say else if value equals 0. Sorry, I got to check the evaluation, not set it. And count. So the next rule was if the cell is dead, but it is touching 3 living cells, it comes to live, right? So if count equals 3 exactly, then self next board row column equals 1. So it's also alive. And then we have our last else, and everything else is not alive. These are the only 2 rules for anything being alive. Everything else is no longer alive. I know I turned 4 rules into 3 rules, but it's not mattering in the programming. So this one will be row, column, and this will be no longer alive. Okay, so now that we've done that, what we need to do is kind of flip these boards over. So I have the board that it's active, that we just read all through, and I put the new values into the next board. And what I want to do is make the next board the board. And do you remember what I said earlier about when we use the equal sign to set a table to another table, it actually just changes the address of it. So it becomes that table. So we're going to take advantage of that. And what I'm going to do is, this is a very common way to swap two values over. I'm going to create a temporary holder for the board. So I'm going to make temp, and this is temporarily going to hold the self board. Okay, so while this is holding self board, now I'm going to change what board equals. I'm going to make board equal next board. So we are setting this value now, but we didn't lose what was here. Okay, so we still have the information that was in board before. We've just told this variable name to now be this address, but temp is holding the old address. Okay, so now we're going to swap it over, and I'm going to say next board is temp. Okay, so all that's really happened here is I've switched board to next board and next board to board. But if I were to not use this temp thing, we would have lost the information in one of them. So I'm temporarily holding the information of what was in board. I'm setting what I want board to be now next board, and now I'm taking next board and I'm putting that information back in that we were holding on to temporarily. So I still have two boards, but now next board has become my normal board to be drawn and displayed and all that stuff. Okay, so that's switching the boards over. There's one other thing I'm leaving out here, is that this is going to rip through really fast now because I'm not delaying the time at all. This is just going to happen at 60 frames a second or something like that. But let's give it a try and see if I have enough code in here. We do need to set up in main. We need to set up the update. So love.update. And we're just linking it up to game update. And we'll find out what errors I've made. Okay. So it's really fast. You can't really see what's happening here. I can't even pause the board right now. Okay. We'll assume that it's going correctly right now, and we just need to slow it down so we can see what's going on. I'm basically going to make a counter so it starts skipping frames. So imagine this game is happening at 60 times a second, and it's updating the board 60 times a second. So we could slow it down. I'll put an initial delay of 8 in, which will mean that every 8 frames that go by, the board will update 1 time. Okay, and we're going to make it so you can adjust that. So up here in the table, I'm going to make 2 variables. I'm going to make a delay target and a delay count. So delay target equals 8, and we'll do a delay count equals 1. So those are just numeric variables. And then back down into game update. I'm going to check if delay count is equal or larger than delay target. Delay target, then. Okay, so I'm just kind of wrapping this. So down here, I need to put another end. Okay, but we're not updating anything yet, so this will never become true. So what we need to do is we need to keep running the counter up. Hold on, this is not at the right level. This board flip, sorry, that was probably a problem. That's probably why the game looked a little strange, but it was happening so fast anyway. This is not at the right level. This should be at the level of the board right here. So the board only gets flipped over when the whole for loop has completed. So these are at the same level. When the whole for loop has completed for the entire board, then the board flips over. So I'm sure it wasn't being displayed right earlier. But after we flip the board over, we're going to add 1 to the count. Or sorry, we're not adding 1 to the count. We're setting the count back to 1. And what I'm going to do is I'm going to add an else. So we have that if statement above. If it's not being tripped, I want to increment the counter. So if it has been tripped and we updated the board, I'm setting the delay counter to 1. If it has not been tripped, if this is a frame that the board is not being updated in, so for 8 frames it doesn't get updated, I want to increment the counter. So we'll have this equal self.delay count, delay count plus 1. So it's going to, every time it doesn't get displayed, it's updating the count until the count is big enough that it equals the target time. When it equals the target time, it's going to go ahead and update the entire board, flip the 2 boards over from the next board to the main board, and then set the counter back to 1. And then it's going to start skipping again until this number gets big enough where it does update. So that if up here is saying if we're going to increment the counter this frame or if we're going to update the board this frame. So most frames we're going to increment the counter, not update the board. So this will slow the game down. Okay, let's see if that works and see what's happening. Okay, so it's slower now and it does look more correct. Well, I can't click and add just yet because we haven't implemented that, but this sort of looks like it's working. This is still life. This is also still life. All these shapes are still life, so it looks like it's working correctly. Delay target, like we can change it right now. Let me just show you this. If we make this smaller, say 1, it's going to be really fast. And if we were to change this number to 64, it's going to be very slow. And we're going to be able to do that here in the next video. That'll allow us to give speed, to change the speed of the game. I want to kind of just change this cell size back to 10 because it's very big. And I'm going to change the border, so that we can see a little bit of a border. I'm going to change it to 1 since the size is 10. And I'm going to change that speed back to 8, which is like a middle ground number. Okay, so this is it running. Now, the next video, we're going to be able to edit this so we can draw our own shapes and everything else and pause it. And yeah, we can't pause it now and do things like that. So I think that's going to end it for this video. I'm going to set up one more video, finish this off and everything. So I hope this was entertaining or you learned something new or just had some fun watching it, and have a good day. Bye.